All right, so this is the second part of our extensions. We talked just briefly about solving some different types of systems and finding the x and y intercepts. Some things that were a little bit more complicated than you were doing before. So you remember we talked about all these questions. And now we're going to move on to graphing these inequalities. We want to graph a system. So you guys have done single inequalities. Now we're going to talk about how to graph. Basically, a system is just two of them at the same time. So we're going to try to draw the graph, and we're going to split this. I'm just going to label these. This is going to be number 1 here, and this will be number 2. And all we're going to do is we're going to look at number 1 first of all, and we're going to draw the line y equals 2x minus 3. So in order to do that, we know the slope from this is 2. That's from right here. And then the y-intercept is minus 3, and that's from right here. So what we're going to do is we're going to get a little grid. We're going to put an axis on that grid. So I'm going to go like this and like this, and then we're going to label our x-axis here and our y-axis here. And to draw this, we go to our y-intercept, and we're going to just put a scale on here. So we're going to go, that's 1, 2, 3, 4, and 5. And we're going to do the same thing here. So that's going to be 1, 2, 3, 4. So 1, 2, 3, 4. There's minus 3. And 1, 2, 3, 4. There's minus 4. So start at the y-intercept of minus 3, which is right here. Color that in. Then our slope is 2, which means we're going to go over 2, or over 1, sorry, and up 2. So that's up 1, and we keep going up 2. There's our next point. So our run is 1, and our rise is 2, and that gives me my line. I'm just going to take my line and draw it through those 2 points. Just bear with me a second. We're going to just take this and move it so it actually goes through our 2 points, like so. Right now, we're going to change the properties of this based on this less than sign. Because it's less than and not less than or equal to, what we're going to do, and you can do this either by drawing it after making this decision if you want to, or you can just take an eraser if you've done it in pencil and just erase little pieces of it. But it needs to be a dashed line because it's not allowed to be equal to 2x minus 3. And then on each end, we're just going to put an arrow so that it continues. All right. So there's our graph. And then you look at that, there's our first equation. Now, it's less than that, and so we have to shade. That's the next part of this. And you can do that in 2 different ways. You can either, just because it's y is less than, and this is less than, you can just kind of go, that's less than 2x minus 3, so you can shade it like that. Or you can use a test point. So you can test, and you may have been shown how to do this, but you can test 0, 0. And what you do is you just, or any point, but 0, 0 is right here. So I'm going to take 0 is less than 2 onto 0 minus 3. I'm going to say 0 is less than minus 3. Okay, that's just plugging in. That's our x, and that's our y. So we go y here, and that's x. And if you look at that statement, 0 is less than minus 3 is not true, which means this, 0, 0, is not a solution. And so that's not the region we're going to shade, so we're going to shade that region. So one or the other will work. You can either just know that it's less than or use a test point. Okay, now that is something you've already done, but we're going to add a second graph. So we'll just change the color so you can kind of see the difference here. But now I'm going to look at the second equation. And the second equation, if we look back up here, is 2x minus 3y. So 2x minus 3y, and we're saying that's greater than 6. So this one we're going to find, like we just talked about, the x and y intercepts using our little 6 divided by 2. Okay, that's 6 divided by 2, which is 3. So our x-intercept is 3 and 0. We'll just put that here. And then our y-intercept, again, just based on what we just talked about in the previous video, we're going to take 6 and divide it by minus 3. So 6 divided by minus 3 is minus 2. So our y-intercept is 0 and minus 2. So what we're going to do, we're going to go up to our graph now and plot that. So 3 zeros right here, and 0 and minus 2 is right here. And then we're going to draw a line through those two. All right, and we're going to try to bend this so that it actually goes through those 2 points. So we're going to try to kind of make it a little steeper and move it down. And then we have to make the same decision we made before. So we're going to go into our properties. And again, this is not something you can do because I'm doing it on the calculator, or on the computer, I mean, but you need to decide whether it's going to be a dashed line or not. And that is the decision you make based on this not having an equal to sign. If it's an equal to sign, it's solid. If it's not, which is not here, it's a dashed line. And again, I'm going to put arrows on the end of each of the sides of the line. Now, I look at this and I say, okay, I need to shade it again. So I'm going to test 0, 0 again. I'm going to test 0, 0 to see if that's part of the solution. If it is, I'm going to shade up here. And if it's not, I'm going to shade down there. So if I test 0, 0, and I'll just write it right here, all we do is plug in 0 for x and 0 for y. So 2 times 0 minus 3 times 0 is is greater than 6. All right, so that means that 0 is greater than 6, and we say that's not true. So we say no, that's not true, which means this is where we're going to shade. Okay. Now it looks a little messy when we do this, but you'll notice that there's an area, and I'm going to try to highlight it for you. There's an area right in here that is colored in both. And then there's an area up here where this is just partly shaded. It's not shaded in red, it's just black. And down here it's red but not black. This region is called the feasible region, or the solution region. Okay, so this is the place down in here where they are both true. Which means if I choose a point and I say, is 2 and minus 3, that's in here, that's a solution to both of these. Okay. Whereas if I choose a point up here, let's say that's 3.5 and 1.5, that's a solution to the first one. It works in here, but not here. And down here, let's say I pick minus 1.5 and minus 3.5, or minus 4, I guess it is. That's a solution to this one. It works in here, but not there. All right. So this region in here that's shaded in both colors, that's the solution region. That is where x and y are allowed to be in order for both of these to be true. So you're used to it being just a single one, and looking at the black, for example, is true here and not here, or the red is true here but not here. So a solution for the system for both is the area that's both of them are shaded in. All right, and that is going to be important when we go to model this as a equation for a situation that we're trying to represent in an optimization problem, which we'll talk about in a minute. But that's the idea of graphing a set of linear inequalities. All right, so here's another system. This time, this has 3. So we're just going to number them again. There's number 1 again, number 2, and number 3. So number 1, I'm just going to write out our x-intercept because it's in the form ax plus by equals c kind of idea, where the x and the y are on the same side. We're going to take 12 and divide it by 1 to get our x-intercept, which is just 12. And then our y-intercept is going to be 12 divided by minus 3. All right, 12 here divided by the minus 3 there, and 12 divided by minus 3 is minus 4. So our y-intercept is 0 and minus 4. Okay, so there's our first equation when we're going to draw that in a moment. But number 2, well, let's go make 2 will be red again. So we'll look at number 2. Our x-intercept is going to be in number 2. It's also one of these equations where it's x, y, and then the number that it's equal to. So it's just the number 6 divided by 2. So that gives me 3. So my x-intercept is 3 and 0, and my y-intercept is 6 divided by 3. So that's 2. So our y-intercept is 0 and 2. So that's our second one. The third one is just a horizontal line. It's just y is less than 2. So we'll draw that one in blue. All right, but we'll just sort of make a little note that this is going to be our blue one. But it doesn't have an x-intercept or a y. It has a y-intercept of 2, but it's just a horizontal line. So I'm going to put my axes in here. So I'm going to go, here's my y-axis, here's my x-axis, and when I label these, whoops, I'm going to just put a scale on here, and I have to go, in order to put the scale on, I have to look at these numbers. I have to get up to 12, so I'm going to go up by 2. So that's 2, 4, 6, 8, 10, 11, 12. It's going to be right here. So we go up by 4 instead. So this will be 4, 8, and then 12. That way we'll get all of them. And then our y-intercept will go up right by 2. So that's minus 2. There's minus 4. All right. And there's 2 and 4 up here.